This is a question asked in 2026 board exam. This is from the chapter Surface Areas and Volumes. This is a tricky question. If you don't visualize how this object looks, you may not be able to solve it correctly. I'll get started. A model of Leafy Ball Fountain is kept on the tabletop. Water gently cascades down the ball. So, how it should look is the water comes out through a small hole on the top, and it fills the place here above the solid surface. So, water gently cascades down the ball into a decorative cylindrical pool. This is the cylindrical pool where it is recycled. So, this is where it gets recycled, as in the water gets into the pore here and from it emerges out from the top, and then it goes back down, and then this cycle continues. The diameter of the spherical ball that is given, the diameter is 21 centimeter, which means the radius should be 21 divided by 2. The cylindrical pool has the outer diameter of 50 centimeter and an inner diameter of 40 centimeter. So this means that the cylinder is not just a solid cylinder, it's a hollow cylinder with an outer dimension and an inner dimension. Height of the solid base, this is the solid base here. So the space above is where the water is collected. Height of the water filled is 7 centimeter. Height of the solid base is 14 centimeter. We'll now take a look at the questions. Determine the total height of the fountain. Now the fountain is a solid object, correct? So it includes this portion, which is of 14 centimeter, and the height of the ball. So in this case it would include the height of the solid base plus the height of the ball, which is nothing but the diameter. You don't include this water because the ball is not above the water level. It is above the solid base, which means you should include this 21 as well as 14 centimeter. So that would be a total of 35 centimeter. Find the volume of the ball. It's a solid ball, so it has a radius of 21 by 2. To solve this, volume is equal to 4 by 3 pi r cube. That is equal to 4 by 3. In terms of pi, that would be 22 by 7. Radius is 21 by 2, 21 by 2, and 21 by 2. So 3 and 21, 7, they get cancelled. 2 and 2 gets cancelled with 4. And there is this 2 and 22, it is 11. So 11 into 441. So the answer would be 4851 centimeter cube. Moving on to the next question. This is where the challenging part starts. Now, read this question carefully. If 1/3 of the ball is submerged in water, remember we have solved similar questions. So, all those questions involved a bit of the Archimedes principle where an object dropped into the liquid makes the liquid either rise in level or the liquid emerges out of the container. But look at this question very carefully. If 1/3 of the ball is submerged in water, there is no spillage of water. If you read this question carefully, there is no spillage of water ever mentioned. Find the volume of the water filled in the pool. So the volume is filled up to the brim, and that would also include the one third of the volume of the ball, correct? So this small cylinder above this solid cylinder, that small cylinder which includes the water, that should be calculated as the volume of the cylinder above the solid. So that should be calculated as the volume of the water plus 1/3 of the volume of the ball. So these two together, they comprise of this solid. This cylinder above the solid. So the volume of water, do we know that? No, we need to find that. That is what is asked. So volume of water, let's keep it as it is. One third of volume of the ball. We just found out what is the volume of the ball. So one third of 4851, and these two together make the cylinder above the solid. This cylinder has a height of 7 centimeter, and it has a radius of the same as the inner radius. Remember, this is the solid portion. So if you were to calculate the volume of the solid portion, you would take the outer radius. But remember, inside where the water is collected, that is a hollow cylinder, not a solid cylinder. For all calculation purposes, for all volume calculation purposes, you will take the inner radius, which is 20 centimeter. So I'm taking the same here. So that would be 20 centimeter. The volume of the cylinder above the solid, that would be, so pi r square is 20 square into h. So that would be 7 centimeter. So to convert this into 22 by 7, we can cancel 7 and 7. Now if we subtract this 22 into 20 square, so 22 into 400, that would be 8 and 0 0, minus one third of 4851, so that would be 1617. That is the volume of water, and that would be equal to 83, and 87 minus 16 is 71. So 7183 centimeter cube. That is the volume of the water collected there in the pool. Find the sum of outer curved surface area. Look at this question. Find the sum of the outer curved surface area of the cylindrical part and the surface area of the ball. So cylindrical part, okay, so that's the CSA of the whole cylinder plus the surface area of the ball. So CSA of the ball. Now this is a sphere, correct? Now the sphere would be touching this part, okay, the solid part. We can imagine like it's a tangent touching a circle. A sphere would rest on the solid part at just exactly one point. So will include the whole of the sphere that can be touched. Whatever area is accessible would be the outer, in this case, the outer CSA of the sphere. We are not going to minus anything because it is going to touch the solid at just exactly one point, and the remaining all of the area would be accessible, which means there is no area, there is no surface area on the sphere that is going to get cut. Whereas there is another part which is a cylindrical part, the CSA of the whole cylinder, that would mean a total height of 14 plus 7, 21 centimeter. So CSA of the whole cylinder, that would be 2 pi capital R H plus the CSA of the ball. So that would be, to distinguish, I'm using different notation for radius, that's it. So CSA of the ball would be 4 pi r square. I'm using the whole of 4 pi r square because no portion is cut from the surface area of the ball. We can take a pi common and a 2 common. What remains is r into h plus 2r, or rather 2r square. So this would be 2 into 22 by 7. This r into h, the radius of the outer portion of the cylinder, that would be 25. The capital R is 25 because that is what is asked. The outer cylindrical parts area we have to find. Outer CSA is what is asked. So this would be 25 into the height. The total height is 21 plus 2 into the radius is 21 by 2 square. So you can cancel off a 2 and another 2. What you can take common out is 21. So 2 into 22 by 7 into another 21. What remains inside is 25 plus there is this 21 divided by 2. So you can cancel 3 times. So 2 into 22 into 3 times of. So this is these two added together would be 35.5. So that is equal to 44 into 3 times of 35.5. So that would be 106.5. So 44 into 5 would be 220. 22 carried over. 44 into 6 is 264 plus 22, 286. So 286, because there is a 0 6, I'm writing it as 6 and 8. So 2 carried over. 44 into 1 is so 4686. And because there is a decimal point here, I'm writing it as 4686.0. This is the outer surface area, the CSA, the combined surface area for the outer cylindrical part as well as the ball. So that would be 4686 centimeters square.